Hello everyone. Today we are going to analyze this propped cantilever beam. In this beam there is a overhanging part BE. In the overhanging part there is no load. Length of the span AB is 6 meter. In the span AB there is a uniformly distributed load 54 kN per meter. It acts for a distance of 4 meter from the fixed end. Also, there is a point load 108 kN. It acts at a distance of 1 meter from the hinged support. Since in the overhanging part BE there is no load, we don't have to consider in the analysis. We know that the upward deflection due to RB will be equal to the downward deflection due to the loads. This is the deflection due to RB, this is the deflection due to the point load, and this is the deflection due to the UDL. We know that in this beam EI is constant. We can eliminate that so that we will get this. Now from the point B and about the point A, we are going to find the moments and then draw the bending moment diagrams. In this case, we have to follow left-hand side rule. Clockwise will be negative and anti-clockwise will be positive. RB is acting in the anti-clockwise direction, so that it will be positive, and the distance is 6. 6 into RB, it will be 6RB. The point load 108 is acting in the clockwise direction, so that it will be negative, and the distance is 5. Minus 108 into 5, we will get minus 540. Let us enter that. The uniformly distributed load 54 is acting in the clockwise direction, so it is also negative. We know that with the UDL we have to multiply the distance and then the distance by 2. When we calculate this, we will get minus 432. Now let us find area 1 x1 bar. We know that it is a triangle. We know the area formula of a triangle, half into BH. Here the breadth is 6 and the height is 6RB. So this is the area. We have to find the centroid distance x1 bar about the right side. The formula is 2 upon 3 into B. Here the breadth is 6, so 2 upon 3 into 6. For area 1 x1 bar, we will get 72 RB. Now let us find area 2 x2 bar. It is also a triangle, so we have to use the same area formula. Here the breadth is 5 and the height is 540. Now let us find the centroid distance x bar 2. We know the formula, which is 2 upon 3 into breadth. Here the breadth is 5, so 2 upon 3 into 5, but we have to add the remaining distance also, because we are finding the moment area about the point B. The remaining distance is 1, so 2 upon 3 into 5 plus 1. For area 2 x bar 2, we will get 5850. Now let us find area 3 x bar 3. We know that it is a second degree parabola. The area formula is 1 upon 3 into BH. Here the breadth is 4 and the height is 432. So this is the area, and the formula to find the centroid distance is 3 upon 4 into breadth. Here the breadth is 4, so 3 upon 4 into 4. We have to add the remaining distance. The remaining distance up to B is 2 meter. So 3 upon 4 into 4 plus 2. For area 3 x bar 3, we will get 2880. In this expression, we have found everything. Let us apply them. In this way, for RB, we will get 121.25. Now let us apply the rule sigma V is equal to 0 and find RA. Now we can take moment about A and find MA. Using the right hand side rule, we can find the shear force values. Here you can see the shear force diagram. In this point, the shear force becomes 0 We can make a section in this point and find the distance. You can see that in that point I have made a section at a distance of x from the point A. We know that in this section the shear force is 0. Using that concept we can find x. Now we can find the maximum positive bending moment. We can use right hand side rule. MA is acting in the anti-clockwise direction, so that it will be negative. RA is acting in the clockwise direction, so that it will be positive, and the distance is 3.754. The uniformly distributed load is acting in the anti-clockwise direction, so that it will be negative. We know that with the UDL we have to multiply the distance and then the distance by 2. For the maximum positive bending moment we will get 136.12. Now let us find the moment in the point A. In the point A we have MA, which is acting in the anti-clockwise direction, so that it will be negative. To find the bending moments in the point C and D, we can use left hand side rule. First, let us find the bending moment at C. RB is acting in the anticlockwise direction, so that it will be positive, and the distance is 2. This point load is acting in the clockwise direction, so that it will be negative, and the distance is 1. For the bending moment at C, we will get 134.5. Let us find the bending moment at D. RB is acting in the anticlockwise direction, so that it will be positive, and the distance is 1. For the bending moment at D, we will get 121.25. In the points B and E, the bending moment will be 0. Here you can see the bending moment diagram. In this point, the bending moment becomes 0. This is the point of contraflexure. In this point, we can make a section and find the distance. You can see that in that point, I have made a section at a distance of x from the point A. We know that in this section, the moment is 0. Using that concept, we can find x. For x, there will be two values. This value is not applicable. So the value of x is 1.51 meter. Now we are going to end this session. Thank you for watching this video.